Well, hi, everybody. Thanks for being here. It's a beautiful day. I just checked. The sun is just now coming out through the clouds and the fog here in Santa Cruz, which is very appropriate for this picture right here. I don't know if you can see it too well, but I'm sure you're all familiar with this common pattern. You see how those sun rays are all kind of fanning out like spokes of a wheel in the classic sunburst pattern? Now, I'm sure you've seen that, but would you believe me if I were to tell you that all those sun rays are actually parallel to each other? It may not look like it, they're sort of fanning out like spokes of a wheel, right? But they are parallel to each other. Consider a couple of railroad tracks that appear to converge to a vanishing point on the horizon. It's the same deal. It's the perspective of parallel lines. Keep in mind that these sun rays are coming towards you. They're coming at you out of the third dimension. Pretty interesting, eh? Think about it. Well, anyway. Now, I've got a big, kind of heavy question for you today. Are we going to make it as a species on the Earth for much longer? Might be kind of a cliffhanger. Seems like we're sort of heading into a perfect storm right now. But in the SETI research community, S-E-T-I, Search for Extraterrestrial Intelligence, the question arises, okay, where are they? How come we haven't been hearing from anybody else out there? Got to do the barefoot thing myself, too. That's how I teach, you know. Well, some people will tell you, well, it's just because we don't yet have sophisticated enough technology or extensive enough sky coverage yet to have been picking up signals. But others say, well, you know, intelligent civilizations with powerful technologies are really pretty rare out there in the cosmos, or they just don't last very long. They inevitably blow themselves up or pollute themselves out of existence or run out of resources or succumb to plagues or some damn thing. Nervous laughter for our future. Now, we do know of ancient civilizations on this planet that flourished for a while and then vanished. But now think about it. Global collapse. Could that be our fate? All right, now look, in the really long run, in the cosmic perspective, there is one thing that's certain, and it's not pretty. Starting in about 1 billion years, the sun is going to go red giant, swallowing the planets Mercury and Venus and vaporizing our oceans. Well, ouch! You know, I never thought I'd hear myself say this, but could that be a case of too much solar energy? And serious global warming, by the way. But hey, that's 1 billion years from now. Not 1 million, but 1,000 million. Oh, whew, what a relief. Okay, but we are going to have to concentrate on getting through these next tens and hundreds of years. And how are we going to do that? Nobody's figured it all out. But there is one great truth. Really good news that you can count on. Any truly advanced civilization of intelligent life here on Earth will have as its key signature that it runs on the sun. Why is this such good news? Energy, as the way we do it today, is the largest and most polluting industry in the world. But the sun is by far the dominant source of energy on the planet, completely dwarfing the sum total of everything we will ever get from oil, coal, natural gas, and uranium combined. You never hear this. It's the best kept secret in the world, but here it is. Take a look at that big cube there. That's the annual total solar energy input to the Earth. And you see that little tiny cube down in the lower right? That's the annual total energy usage by all of civilization. And those other sort of largish dark boxes, those aren't the annual energy supplies from the fossil and fissile fuels. Those are the total remaining reserves left in the ground. So hey, this picture is kind of like manna from heaven. And especially if you're interested in lots of really great new jobs where people can make a good living, helping make a difference for a better world, there's good news here, and lots of it. Now let me show you a picture of one of my favorite sky phenomena. Can't tell how well you can see it from out there. It shows up okay here, but can you see, we're looking away from the sunset, toward the east in the evening. So first of all, what's that white thing there? When the moon is full, it's always more or less opposite the sun. But do you notice the contrast between this dark zone, narrow dark zone down here, and this much larger, brighter zone above? Now, I'm sure you've all seen this probably many times, and maybe you thought that dark stuff was smog or something, but you actually see it best on the cleanest, clearest days. Now I'm going to give you one more hint about what that is. This whole pattern is rising in the east as the sun's going down behind us in the west. It's the shadow of the earth on the atmosphere. The air actually acts as kind of a projection screen for the shadow of the horizon behind you being cast out onto the sky ahead of you. And now, do you also notice kind of a little pinkish orange horizontally oriented fringe along the boundary line there? That's the last direct rays of the setting sun hitting the atmosphere. It's called the alpenglow. You don't have to be in the Alps to see it, though. You can see it here or anyplace else. And this whole picture, well, actually, I got to tell you, before I finally get to the point here, when I was a kid, there were these two soap operas on afternoon TV. One of them was called As the World Turns, and the other one was called The Edge of Night. Some of you may remember that. Well, folks, this is the edge of night as the world turns. You know, at our latitude on the Earth, we're rolling about 800 miles an hour towards that day-night boundary. So this picture kind of symbolizes the night and day contrast between the way we've been doing energy in the world, you know, analogous to that shadow zone there, and the way we have to start doing energy and can do it from now on if we're going to make it. The way we do energy now is literally harnessing the powers of darkness, oil, coal, gas, uranium, things we have to dig up from underground, largely in places where we've now largely made ourselves unwelcome, making a huge mess everywhere we do it and every time we use the stuff. Meanwhile, the sun yet shines on the great majority of this scene, representing this vast resource whose enormous potential we've barely begun to tap yet. The sun and all of the renewable energy sources derived from or related to the sun, the winds, which are caused by the sun, the waves, which are caused by the wind, green plants, which grow under the light of the sun, falling waters, which were raised into the sky by the heat of the sun, as well as ocean thermal power, where we can utilize the temperature differences between the sun-warmed surface layers and the cold depths. And then there's lunar tidal power and geothermal earth power. Together, these provide in less than 1 hour enough energy for all of humanity for a whole year. And humanity's energy usage at present is really very wasteful. So hey, if we move towards more smarter, more efficient infrastructure and towards wiser, more community-oriented energy habits, and that's a shout out to the transitions movement, we'll have a much more manageable problem. All of these, especially the big one, the sun, are clean, limitless, homegrown, and democratically distributed. It doesn't get much better than that. Together, these hold the keys to eliminating, or at least greatly reducing, what in my book are the top problems that humanity still needs to grow up and deal with: poverty and war, while promoting the health of the entire biosphere and revitalizing our global economy with a multi-trillion-dollar revolution to the future, where at last we can have widespread, reasonable, decent levels of wealth worldwide. Okay, so what's the problem? Why aren't we there yet? Or at least well on our way? The main reason is we haven't even been really trying yet. You want to see a picture of how we've been spending our resources for energy over the past generations? There you go. That tall bar is the money we've been throwing at the dinosaur energy technologies of the smokestacks and radioactivity economy. The little short bar is what we've been investing in our future. Okay, so folks, we got to turn the tables on this picture and do the research and development, the basic research like we used to get the costs of solar and the other renewables down, and then the political work to bring up the costs to where they should be of the cheap and dirty stuff. What's been lacking is education of ourselves and our leaders so people know what's even possible and we can get the political will together to take on this enormously difficult, radical, wholesale sea change, and spending on the right things for a change. For anything we decide is good, important work worth paying people to do, we can and must spend, which will increase the spending power of the people doing the work and enrich economic activity overall. It gets the job done while getting the jobs going. Now, just so you know how real this potential and promise of renewable energy is, guess what country in the world has deployed half of the world's solar electric arrays, a technology that was invented here in the United States, by the way. I'll give you a hint. It's a cloudy, small country in northern Europe with a solar resource about like that of Alaska. Germany has done this with intelligent, wise vision and leadership translated into public policy. Okay, well now just a couple more pictures of favorite sky phenomena as kind of visual metaphors, and then it's time to go eat some stored solar energy, i.e. lunchtime. This is a picture taken by one of my colleagues here at Cabrillo College, Rick Nolthenius, of one of the wonders of the world, a total eclipse of the sun. And by the way, I can't wait. The next one that crosses our entire country is only 6 years away, 2017. When you're in the middle of the round shadow of the moon on the earth, you get this 360-degree sunset glow all the way around the horizon. It's amazing. And there's this amazing coincidence that the moon is 400 times closer than the sun, but also 400 times smaller than the sun. What does that mean? It means it just exactly fits in front of the sun. Enables you to see all these marvelous phenomena, and that's a coincidence that's probably not duplicated many other places in the galaxy. So you know what? I tell people, hey, if aliens are coming here, maybe it's to see our eclipses. Now these bright magenta prominences here around the edges, those are huge plasma eruptions, bigger than the Earth. Now, we actually already have all the nuclear energy we need in that gigantic wireless fusion plant in the sky. And the way we harvest solar energy at present for electricity is using the second most abundant element in the Earth's crust, silicon, the stuff of rocks, second only to oxygen from all the water in the oceans. But this picture kind of shows you where we are and what we're up against. We're in the dark with a real fight on our hands. Our democracy is in danger of being turned into a racket by powers that be that are blocking our main path to sustainability. So we have to move them aside, take back the day, and let there be light. Sky power to the people. Now, we're not quite done yet. Let me just leave you with that fabled atmospheric phenomenon of the green flash, where the top edge of the sun momentarily turns emerald green just as it's meeting the horizon, either at sunset or actually, even better, at sunrise. Robert Frost had a line in one of his poems, "Nature's first green is gold." We truly are at the dawn of a whole new golden age of green cresting on yonder horizon, on the very cusp of one of humanity's greatest projects ever, the solarization of the world. Let's help create that wave and then surf it. Keep an eye on the sky. Sky power to the people. Thank you so much for everything you do out there.